Here we're asked to find the inverse of this function. The first step is to replace the notation here, f of x, with y. So that'll leave us with 2x plus 1 over x minus 3. Okay, the second step is to switch the roles of x and y. So in this case, x equals 2y plus 1 over y minus 3. Okay, and then we have to solve for y. And that's where it gets a little bit tricky. On this one, what I'm going to do is multiply both sides by the quantity y minus 3. That'll leave us with x times y minus 3 equals, here the y minus 3 cancels, so 2y plus 1. Okay, and then distribute the x. So we'll have xy minus 3x equals 2y plus 1. Okay, and this is what we want to do. We want to get our y terms on one side and our x's on the other side. So we could do that by first adding 3x to both sides, and at the same time we can go ahead and subtract 2y. These aren't like terms, so let's keep them separate. xy minus 2y then would equal 1 plus 3x. Okay, and this is the key. Do you see how y on the left side is now a GCF? So if we factor that out, what we'll be left with is x minus 2. Okay, so we can get y by itself now by dividing both sides by the quantity x minus 2, and that'll leave us with y equals 1 plus 3x over x minus 2. Now for the last step, what we're going to do is replace y with the notation f inverse of x. And you can see here what I have is f inverse of x, that's my y, equals 1 plus 3x over x minus 2. That's the inverse of the original. So keep this little trick in mind. If you get all your y terms on one side, it then becomes a GCF. And you can factor it out and then divide out whatever's left.